Hey guys, this looks like a fun one. We're given a circle inscribed inside of a pentagon, and it wants us to find the area of the circle. We're not told it's a regular pentagon, but I'm pretty sure it is. Not only are all the sides congruent, but the circle is tangent on all these points. I think this will only be possible for it to be tangent at 5 places if it were a regular pentagon. There's probably proof of that somewhere. And we're also given that the side lengths of the pentagon are equal to 2 times the square root of the quantity 5 minus 2 root 5. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, let's draw this diagonal perpendicular to this tangent point. And we can do it over and over and over again till we have all 5 of them. All of these will intersect in the center of the circle, and this is going to split up this 360 degrees evenly so they're all 36 degrees. Each of these are a part of 10 congruent right triangles. I just want to focus on one of them. Let's do this one here. And then since this was the center of the circle, this is going to be equal to the radius. Let's call it R. Now let's copy down a zoomed in version of this triangle right here. This base is equal to half of this right here. Since the whole thing is 2 times the square root, this is going to equal 1 times the square root. And this one isn't going to matter, so let's get rid of it. Now we have a really fun looking right triangle. Since this is a right angle, these 2 angles have to add up to 90 degrees. So this angle down here is going to be 54 degrees. And now let's find the tangent of this 54 degrees. Tangent is equal to opposite over adjacent. This opposite is equal to R, and the adjacent is going to be equal to this whole thing. Next, to get the R all by itself, let's multiply both sides by this denominator. On the left-hand side, we'll be left with this times tangent 54, and on the right-hand side, these are going to cancel each other out, leaving us with R. And now we have our value for R. So it'll be pretty easy to find the area. The area of a circle is equal to pi R squared. Let's move the R over here to give ourselves some room, because we got to substitute all of this in the place of the R. Now we have this square root times this tangent, whole thing squared. Since these are being multiplied, this square can go to each of them. So we can rewrite it as this thing squared times the tangent 54 squared. For this first parentheses, the square root and the square are going to cancel each other out. So we're left with 5 minus 2 root 5. And then for this tangent 54 squared, you typically see the squared here. So let's move it over. This is basically the answer to our question. We can put a box around it, but I want to see if we can go a little bit further. Let's see if we can clean it up a little bit. Find a way to simplify this tan squared 54. There's one fun trick you can always do. Since we have double angle formulas, triple angle formulas, quadruple angle formulas, quintuple angle formulas, and so on, you can try multiplying whatever angle you have times different numbers to see if you get something you recognize. So we can do 54 times 2 or 3 or 4 or 5. 54 times 2, we get 108. I don't know how to do anything with that. 54 times 3 is 162. Same thing, I'm not sure what to do with that. 54 times 4 is 216. I still don't know what to do with that. And then 54 times 5 is equal to 270. I do know what to do with 270, so let's play around with that. If you have a circle on the XY plane, you can draw the 270 degrees like this, and you can make a triangle at this 270 mark. The triangle is very, very skinny. In fact, it has 0 width. So if we were to try to draw the triangle like this, we would have to call this top side 0, because basically it has a width of 0. And then these 2 sides are the exact same side. We can call them anything we want. Let's call them 1. What's most important is that they're the same length. So this is going to be our reference angle. And now we can find the tangent of 270 degrees. It'll be the opposite over the adjacent. The opposite here is equal to 1, and the adjacent is equal to 0. And 1 divided by 0 is undefined. So we know that the tangent of 270 degrees is undefined. Let's see if we can use that fact to find the tangent squared of 54. Since we ended up multiplying the 54 times 5 to get 270, we're going to use these notes for the quintuple angle formula. So using these notes, the tangent of 5 times 54 degrees is equal to tan to the 5th of 54 degrees minus all of this divided by 1 minus all this. Now 5 times 54 was equal to 270, and we know that the tangent of 270 is undefined. And this whole thing will be undefined when this denominator is equal to 0. So we can set all of this equal to 0. And now let's see if we can do anything with this. Let's clean this up with some substitution. We can set x equal to tangent squared of 54 degrees. And that means x squared is going to be equal to tangent to the 4th power 54 degrees. Now using these, we can do some substitutions. This whole thing can change into 1 1 minus 10x plus 5x squared. And now we have a quadratic. Let's rewrite this in descending order, and we can do the quadratic formula. It'll be x is equal to negative b plus or minus square root of b squared minus 4ac, whole thing divided by 2a. After we clean up under the square root, this will be 100 minus 20. So we're going to end up with x is equal to 10 plus or minus root 80 over 10. And then for the square root of 80, we can split it up into 16 times 5. And then each of these can get their own square roots, and the square root of 16 is equal to 4. Now, each of these are being divided by 10, so let's make it into two separate fractions, each being divided by 10. For the first one, 10 divided by 10 simplifies to 1. And for the second one, we can simplify the 4 over 10 to give us 2 over 5. And now we have two values for x. But if you remember earlier, x was equal to tangent squared 54. So in the place of this x, we can plug in tangent squared 54. Now, since this is tangent squared, it has to be a positive value, so this minus version will not work. So tangent squared 54 is equal to 1 plus 2 root 5 over 5. And tangent squared 54 is what we were trying to solve. So now let's copy this whole area formula down here. And in the place of tangent squared 54, let's plug in all this. And now let's copy down the area in the pi and let's multiply all this out. 5 times 1 is equal to 5. And then when we do 5 times this, the 5 on top and the 5 on bottom are going to cancel, leaving us with 2 root 5. And then when we do this negative 2 root 5 times 1, that'll give us negative 2 root 5. And then negative 2 root 5 times 2 root 5 over 5, negative times positive is negative. 2 times 2 is equal to 4. Root 5 times root 5 is equal to 5. And then we saw the 5 on bottom. And then this 5 on top and this 5 on bottom can cancel each other out, leaving us with 4. Next, this positive 2 root 5 and this negative 2 root 5 are going to cancel each other out, leaving us with 5 minus 4. 5 minus 4 is equal to 1, and 1 times pi is equal to pi. And that is the answer to our question. Let's give it a label of square units and put a box around it. In this given regular pentagon, the inscribed circle has an area of exactly pi square units. How exciting.